Welcome back, Mathvillians. Here we go. We're going to solve linear inequalities in one variable. This is review really from Algebra 1, so we're going to take it kind of fast here, folks. Hang on. Okay, so we're going to solve a linear inequality and solve and graph this. 3 minus 2x is less than or equal to 11. First we need to solve it, then we need to graph it. If I subtract 3 from both sides, I have minus 2x is less than or equal to 8. Now I'm going to divide by negative 2, and I get x is greater than negative 4, because when you multiply or divide by a negative number and you're using an inequality, it flips the sign around. So this graph is going to be x is greater than negative 4. There's my negative 4. There's my bracket at negative 4 and my arrow to the right. Let's try solve and graph. Minus 2x minus 4 is greater than x plus 5. So for this one, I'm going to go ahead and bring my positive x over to the left-hand side. And I do that just because I know that I'm going to have my x on the left and my number on the right in order to be able to graph it, so I'm just going to start with that. So now if I add 4 to both sides, I have negative 3x is greater than 9. And when I divide by negative 3, I have x is less than negative 3. So my graph is going to be starting at negative 3, not including negative 3, so I'm going to use a parenthesis, and I'm going to go to the left. Oh no, not fractions. You know, I'm always going to throw some fractions in there. I know everybody wants to just get rid of fractions entirely, but it really isn't all that tough. Here is my equation. X plus 3 over 4 is greater than or equal to x minus 2 over 3 plus 1 over 4. We can make this a much easier problem if we eliminate the denominator. To eliminate the denominator, we have to decide what would the common denominator between 3 and 4 be, and it's 12. So we're going to multiply everything by 12. But before I do that, because I don't have just singleton numbers above my denominators, I actually have numbers that are added or subtracted, I'm going to put them into parentheses. So when I distribute the number, I come out with the right answer. So I'm going to put a 12 in front of each one of the elements. I'm going to multiply each element by 12. So for the first one, 4 goes into 4 once, 4 goes into 12 3 times. For the second one, 3 goes into 3 once, 3 goes into 12 4 times. For the third one, 4 goes into 4 once, 4 goes into 12 3 times. So I have gotten rid of everything that's in the denominator. Now I have 3 times the quantity x plus 3 is greater than or equal to 4 times the quantity x minus 2 plus 3 times 1. Now this makes it a much easier problem to work with. Don't have to deal with those pesky denominators and fractions. So when I distribute the 3, I have 3x plus 9 is less than or equal to 4x minus 8 plus 3. I'm going to clean this up. I have 3x plus 9 is greater than or equal to 4x minus 5 because I have I put together the negative 8 and the positive 3. And now I have 9 is greater than or equal to x minus 5, or 14 is greater than or equal to x. I need to change that the other way around because I need the x to come first. If you notice, the alligator mouth is open towards the 14. So when I switch them around, the alligator mouth also has to be open towards the 14. In other words, I'm reversing my sign. So I have x is less than or equal to 14. Here's some weird solutions. If I have 2 times the quantity x plus 4 is greater than 2x plus 3, and I solve this one, I'm going to have 2x plus 8 greater than 2x plus 3. If I subtract 2x from both sides, I have 8 is greater than 3. Well, my x is gone, so I really don't have much to do here except to see that x is greater than 8 is true. And it's always going to be true. X will always be greater than 8. If you come up with an answer like that, then you know that any solution is going to work. X is going to be the set of all x such that x is a real number, or you could say the solution set is negative infinity to positive infinity, because any value for x will work if you wind up with a true statement. On the other hand, if I have x plus 7 is less than or equal to x minus 2, and I subtract x from both sides, I have 7 is less than or equal to minus 2, that is false always. So if I come up with my final answer will always be false, that means that there is no solution. It's the null set. Okay, go do your checkpoints and move on. See you later.